We continue our unit on logarithms with solving a logarithm. In these examples, I need to find out what x is. In the first example, we have log base 7 of x equals 2. Well, this is the same thing as saying 7 raised to the second power is equal to x. So that means x is equal to 7 times 7, which is 49. Let's look at the next example. Log base 2 of 64 equals x. So 2 raised to some power x equals 64. I could do this one of two ways. I can ask myself, how many 2's are in 64? Or I could change 64 to a base 2. 64 can be rewritten as a base of 2, 2 to the 6th power. And that is equal to 2 to the x. So now that the bases are the same, we can set the exponents equal to each other and solve. X equals 6. There are 6 2's in 64. Let's look at the next example. 2 raised to the 4th power equals x minus 9. 2 to the 4th power is 16, and that's equal to x minus 9. When we add 9 to both sides, we get x equals 25. Next example. Notice I am solving now for a log, and I have other things around the log. So remember, just like if I would have had an equation 15 plus 2x equals 25, I would subtract 15 from both sides first, then divide by 2. And next would be equal to 5. Remember, I practically do the same thing when I'm solving for a log. I want to isolate the logarithm first. So this whole thing right here is what I want to isolate. So I'm going to put a box around it. The next thing I do is get rid of the 15, because we are doing PEMDAS backwards. I want to get rid of anything adding or subtracting first. So there's a 15 here, so let's subtract 15 from both sides. 15 is being added to the log. So I have 2 times log base 2 of x equals 10. There's nothing being added to the log. However, there's a 2 being multiplied to it. So now I get rid of the multiplication division. That's the second step. So divide both sides by 2. At this point we have log base 2 of x equals 5. I still do not know what x is. So I have log base 2 of x equals 5. Now I rewrite just like I did in this first example over here on the left. 2 raised to the 5th power equals x. X is equal to 32. Now let's look at this example. Notice I have a log on both sides. So this is just like having letter terms on each side and a number term. So I want to move all my letter terms to one side, all my number terms to the other. So that means I'm going to add 2 to both sides to get rid of the 2 on the left side, and I'm going to add a log base 8 of x to both sides. This will give us log base 8 of 4 plus log base 8 of x equals 2, because that cancels out as well. Now let's use our property to condense our logs so that we have a logarithmic expression. And remember, when there's an addition sign in between, we can use the property that allows us to multiply the 4 and x together. So log base 8 of 4 times x equals 2. Now we can solve. 8 to the 2nd power equals 4x. And what is 8 to the 2nd power? Well, that's 64, because 8 times 8 is 64. 64 equals 4x. divide both sides by 4, and x equals 16.